Thank you all of you for joining today's session. In our today's discussion, we'll talk about one of the qualitative analysis listed in our chemistry laboratory experiment. We have already learned the qualitative and quantitative analysis in main branches of chemistry. In analytical chemistry, we can separate all the three major steps in separation and isolation, which is mandatory for both of the analysis, qualitative and quantitative, then the identification and determination. Identification involves the characterization of any chemical species present in a sample, and determination involves the measurement of the amount of that particular chemical species in a mixture or in a sample. So, depending on that perspective, we can subclasses, we can divide the chemical analysis in two categories. One is qualitative analysis, another one is quantitative analysis. Qualitative analysis, as I told, we usually identify what is there, and quantitative analysis, how much that substance. So what and how much. In the flame test, we would like to identify what is there. So it is belonging to the qualitative analysis. Now, from the name, I think you can guess that flame. Usually, we have gone through the source of flame in chemical laboratory or chemistry laboratory is the Bunsen burner, where I use the natural gas to create the flame. And we talked about there are two types of flame in our last session. One is the luminous flame, another one is non-luminous flame. And we can control the creation of luminous and non-luminous depending on our purpose, what we are going to do. Depending on that, we can control, we can regulate, we can intentionally create the luminous and non-luminous flame. Luminous flame itself is a yellowish or reddish color. When we do not allow the oxygen in the air to burn the natural gas completely. So the partial burning of natural gas is creating the luminous flame, which is usually less hotter or hot than the non-luminous flame. So just by controlling the access or controlling the flow of air, especially the oxygen, into the burner, we can create the luminous flame, which has reddish or yellowish color with less hotter flame. Sometimes this flame is also called safety flame because we can easily identify the existence of flame because of its color. On the other hand, the other one is a non-luminous flame, which is very light bluish color having inner and outer cone. It is expected that the inner cone will have the highest or the hottest part of the flame. So it is created when we allow the oxygen or the air through the air hole by opening the collar, which is at the below of the Bunsen burner. And this oxygen will completely burn the natural gas in the which is coming to the Bunsen burner, and thereby producing non-luminous flame. Now, in the case of flame test, as this test is depending on the color of the flame, so we need to create a non-luminous flame to identify the change that is happening to the flame color, because the very basic of this test is to observe the flame color and identify the existence of metal ion. Here we are going to identify the metal ion, which is called cation. Metal ion or positive ion or cation, especially the metal ion here, because hydrogen is also positive ion, but we cannot identify from here. We can only identify the metals present in any ionic compound. Ionic compounds are two types. One is binary ionic compound like sodium chloride. Two monoatomic ions are there, sodium and chloride. Other one is ternary ionic compound. In ternary ionic compound, there is one, at least one would be polyatomic ion. And polyatomic ion, you're already been familiar with the polyatomic ion like sulfate, sulfide, phosphate, phosphide. These are the polyatomic ion. So when sodium is connected with carbonate, we call it sodium carbonate, and that is ternary ionic compound. So whatever the binary ionic or ternary ionic, no matter, if there is any metal, we'll be able to identify the existence of metal by observing the color of the flame. So that's called the flame test. And if you ask me what is the main objective, yeah, definitely the main objective of the flame test is to identify the metal or cation. So here we would like to focus on the objective or the aim of this test. Whenever we are going to design any experimental procedure or any experiment, we need to identify what is our objective, what we are going to do, why we are carrying out this experiment, what it will help us to get or identify or find out or determine. So here, just for your understanding, what we can get the idea or the objective of flame test: to explore the line spectra or variety of elements by heating them in a Bunsen burner flame. Which type of spectra they will produce? In our last theoretical class, we started the radio electromagnetic spectrum, electromagnetic radiation, electromagnetic wave. They can produce different spectrum depending on the wavelength. Some are visible, some are invisible. So as these are related to the observation of flame test, definitely they are going to produce the visible light. Otherwise, without naked eyes, we cannot differentiate, we cannot identify the existence of the element through the observation of flame color. So to explore the line spectra of a variety of elements by heating them in a Bunsen burner flame, the data gathered from the flame colors created by the elements will be used to identify some elements present in unknown solution. So we are going to find out or identify the elements, especially as I earlier told, later on we will show you, to get the idea about qualitative analysis. So it is one of the techniques where we get the idea of the qualitative analysis. And last four is identification of metal ion in a compound. So what I told you, the identification of metal ion, we can only identify the metal ion by this flame test. Unfortunately, we cannot identify the non-metallic part. For identification of non-metallic part, we need to design other type of chemical experiment, which will be discussed later. So you can also consider that this is one of the limitations of this flame test. This is one of the limitations of the flame test, that we cannot identify the non-metallic part in an ionic compound. So these are the objectives of the flame test, or aims, or the reasons of carrying out this test. Now I would like to discuss about the theoretical background of this flame test, which is important to understand the procedure. Electromagnetic spectrum, when a charged particle is vibrating, we can expect the production of electromagnetic wave or electromagnetic radiation. Our main target to identify the wavelength or identify the electromagnetic spectrum which have the wavelength started from 380 to 740. So this is the lowest. If the wavelength is shorter than this, we cannot identify. If the wavelength is longer than this, we cannot identify by our naked eyes. So what we can only do, if the uh, electron or if the element is producing the wavelength of 380 to 740 nanometer, then we can only identify their color, started from the violet bluish color to the red color. That's why the shorter than this wavelength called ultraviolet X-ray gamma ray, which we cannot identify by our naked eyes. On the other hand, longer than this 740, which is called infrared, microwaves, radio waves, other communication waves are also. So what we can expect in our process, in this experimental procedure, we can only produce the electromagnetic spectrum having the wavelength from 380 to 740 nanometer. Longer the wavelength, if the wavelength is longer, the frequency will be short and energy will be low. On the other hand, when the wavelength is shorter, the frequency will be high, energy will be high. So there is a relationship between wavelength and frequency, as well as frequency and energy. So from there, we can also derive the relationship between wavelength and energy also. From here, we can understand that longer the wavelength, shorter the frequency, or lower the frequency, lower the energy. The wavelength is inversely proportional to frequency of an electromagnetic wave, and frequency is directly proportional to the energy. Higher the frequency, higher the energy. So when wavelength is inversely proportional to frequency, wavelength is also inversely proportional to energy, because frequency and energy are directly connected to each other. Here you can see the image of the flame of the Bunsen burner. So this was the non-luminous flame earlier, but when some salt or compound containing lithium, that it shows very red color, crimson red color. Sodium will produce some yellow color. Potassium, it should be purple, lavender, or violet. Though the image, due to the image distortion, we don't the color here, but when we will carry out this experiment in our laboratory, you will get very clear and distinctive color. And when the compound containing copper, the flame color will suddenly changed into green color, very nice green color. However, this green color is not much visible here, as I told you, to the image distortion. Actually, what is happening in this case? When we are putting the compound on the Bunsen burner flame, this electron in the compound or the element is absorbing the energy and become energetic. So that will jump to the higher energy level, from lower to higher energy level. Now that is its temporary situation. And once it has become excited, it will again come back to its original state. Now, when it is going to higher energy level, it is absorbing the energy. Now, when it is coming back to its original state, it will release the same amount of energy. So it is related to energy. Now, energy would be in the form of electromagnetic radiation. The energy that will be released by this electron will be in the form of electromagnetic radiation. And that electromagnetic radiation will have some wavelength, and depending on the wavelength, we can get the color. So if the wavelength is shorter, the color would be like purple or lavender, violet or blue. If the wavelength is longer, it could be orange, red. Like here, if we talk about the lithium, we can see the red color. That means it is producing the electromagnetic radiation having longer wavelength, and longer wavelength means weaker energy, so low energy. But when we had been talking about the production of color, like here, the potassium, violet or purple color or lavender color, it has a shorter wavelength, means higher energy. So we can expect that potassium will produce higher energy. That's why it has a shorter wavelength and we can get this color. On the other hand, lithium will produce less energy and will have a longer wavelength, which will tell us about the red color, crimson red color, because of its longer wavelength. It is just the excitation step from lower energy level to higher energy level, and it will go back to its higher energy level to lower energy level. The absorption of energy and the release of energy will be equal. What do we need in this experimental procedure? Bunsen burner, which will be the source of energy. Watch glass, platinum ware. Here, I would like to tell you is whenever I'm describing anything which is not mentioned in the slide or the document, is focus them carefully, listen them carefully. These are important. Platinum ware. Most of the cases we use the platinum ware. If this platinum ware is used to identify the existence of the metal ion in a compound, this platinum, gold, we know that they are noble metal, and usually they do not go for any chemical reaction with other substances. So to avoid the contamination of the flame color, we usually use the platinum ware, because platinum ware will not produce any flame color, any change in the flame color. So we will get the exact flame color, which will be produced by the existence of that element, metal ion. So we are using platinum ware because why the platinum ware will be used to take the salt or take the compound and to hold on the flame, which will change the color. So platinum ware, the platinum ware is used because it is not going to make any reaction with the element or the compound. Then the beaker. Salt means the compound that we are going to analyze, or it is called analyte. Here, rather than salt, we can call it compound also, or sample. Hydrochloric acid diluted. Why hydrochloric acid will be used? It has two clear purposes. One, hydrochloric acid will be used to make solution of a particular compound, which we are going to analyze. And second one is hydrochloric acid is used to clean the platinum ware, because the same platinum ware we are going to use for using all the compound, the same platinum. We have different compound, but only say one platinum ware. That's why it need to be clean to remove any contamination. So when we use the platinum ware for identification of sodium in sodium carbonate, and if we use the same platinum ware for the identification of copper in copper 2 nitrate, then the sodium can contaminate. That's why before moving into another compound, before taking the another compound in the platinum ware, we need to clean the platinum ware. So how to clean it? Usually dipping the platinum ware in the dilute hydrochloric acid, then put on the flame. So the flame will burn any kind of contamination and the platinum ware be clean. So first, the purpose of using hydrochloric acid is making solution and cleaning the platinum ware. Here you can see the procedure. The platinum wire is connected with a glass rod because the platinum wire is conductive that can carry out the thermal energy throughout its shaft. That's why glassware will not circulate that energy to your hand, so your hand will be safe. So this platinum wire, there will be a bead-like portion or coil-like portion which will be stuck to the compound connected there. Then when you put that compound on the flame of the Bunsen burner, the flame color will be changed. So the procedure: dip the wire in an acid solution, hold the wire in Bunsen burner flame, place some of the salt on the wire, hold the salt in the flame, note the color, note the color imparted to the flame. Repeat for all other compounds or salts. Record your results in flame test chart using different colors. Use the first table to fill in. We have the table later and I will show you in another document. So you can also think, ask one question that if we want to make the solution, why we are not using the water? Because water is the best solvent. Water is the universal solvent. It has the ability to dissolve most of the compound. Yes, that is true. But at the same time, there are some compounds which will not be dissolved in the water. That's why to avoid that restriction, we are using the dilute hydrochloric acid, which will dissolve all the analytes or compound that we are planning to identify. That's why we are using hydrochloric acid. All right, I'd like to go back to our document where the limitations and the table will be displayed. Experiment 2, qualitative inorganic analysis, identification of cations by flame test. The objectives, what we have already described. Theoretical background I have described earlier. The apparatus, procedure. Here is a chart which will help us to find out the existence of element by using the color. Like copper 2 non-halide will show green color, potassium violet color, sodium intense yellow or golden yellow color. Here usually in our chemistry laboratory, we analyze this usually up to now around the 6 compounds are analyzed: sodium carbonate, potassium iodide, copper 2 nitrate, lithium carbonate, iron 3 chloride, calcium nitrate. So these are the molecular formula, what table I have been talking about. Whenever after the analyzing, we will list the compounds with their compound chemical name, with their chemical formula. What we identified only the metallic part. So from sodium carbonate only sodium ion, potassium iodide only potassium, copper 2 nitrate only copper, lithium carbonate lithium, iron 3 chloride iron, calcium nitrate calcium. So here what would be the color? Yellow, the sodium, lavender, potassium, green, copper, red, lithium, crimson red, golden yellow or sparkling yellow. You can differentiate these two yellow, iron, and brick red, that is calcium. So you can easily differentiate between the red of lithium and red of calcium. What would be the limitation? Earlier I told you the first limitation is we cannot identify the anion or the non-metallic part by using this flame test. Second one is that you can find out there are some of the element which is producing same color, say arsenic blue color, cesium blue color, copper 1 blue color. Then if that is blue color, how we can identify which one is arsenic or cesium or copper, or also indium also having a blue color. So it is not so specific. It is a little bit cross, but very simple technique to identify many of the elements. So this is another limitation. The same color would be produced by different elements. And another thing, if the sample is very lower amount, very small amount, we cannot detect that, as this is not so sophisticated analytical process, so that if there is very small amount, trace amount, that will not be detected by flame test. So these three are the basic limitations. Other limitations are also there, you can go through them for learn. And after the later I will share the video demonstration with you, so that you can get idea how the experiment will be carried out. But we will also do it in our chemistry laboratory in the campus. So just for your understanding, as I have described all the theoretical background and anything required to understand this, just the demonstration will be shared by using a video tool. And one thing I like to tell you, and in our next Thursday class time, during the class time, I have planned to take a test class test, because we have already discussed three topics, very important. First one was the laboratory safety rules, which is very essential for us to learn, so that you can learn. And second, we talked about the functions, identification, functions, and operation of the laboratory apparatus, which is also very important for carrying out any chemical experiment in the chemistry lab. And today we talked about the flame test, which is one of the important qualitative analysis in our experimental process. So these three will be the topic. So learn them very carefully. Go through the lecture record from the Google Classroom and learn them. In our next, during the class time, the written exam will be held. Just for your reference, I'm reading the limitations of the flame test, which are also important. The test cannot detect low concentration of most ions. Low concentration cannot be detected. The brightness of the signal varies from one sample to another sample. Brightness. For example, the yellow emission from sodium is much brighter than the red emission from the same amount of lithium. The brightness, however, if we have any problem with the visual ability, then that could be making that problem. But usually this is not a big deal. We can differentiate that. Impurities or contaminants affect the test result. That's why we are going to thoroughly clean the ware that we are frequently or repeatedly using. Sodium in particular is present in most compounds and will color the flame. So if there is an impurity in the compound, that can change the flame color. Sometimes a blue glass is used to filter out the yellow of sodium. If required, then we can do this. The test cannot differentiate between all elements. We have already identified that there are many elements showing the same color. Then how we will identify that? Several metals produce the same flame color. Some compounds do not change the color of the flame at all. So you will get sufficient information from that PowerPoint slide that I have shared with you, discussed from there. And also this document will help you to understand whatever necessary. So the documentation is enough for your understanding any part. Also, you can go through the report if necessary. Now, in our another session, because so this will help you to understand anything regarding the experimental procedure or theoretical background, objective, then limitations, data, and the table, how we will describe the result. And as I earlier told, in our next uh, lab class, during lab class, I'm planning to take a test on the three topics. One is the lab safety rules, identification and functions of lab apparatus, and flame test.